Welcome to the Trend Detection Podcast, powered by Siemens. And now your host, Niall Sullivan.
Hello, and welcome to this episode of the Trend Detection Podcast. I'm joined today by my colleague, Chris Garrison, all the way in the US, in a much more exotic location than me. Not that I'm jealous at all, but yeah, today we're talking about something a bit more, I'm going to say a bit more technical than usual, and something that's a bit different to what we've discussed before. And it's actually vibration spectral analysis, which we'll go into the reasons sort of why we're focusing on that topic. But yeah, I'm excited to dive into a completely different topic to what we've done before. So I guess before we go into it, just hand over to Chris to introduce himself. So over to you, Chris.
Yeah, thanks, Niall. Chris Garrison with Siemens Senseye. Been with the organization about a year and a half now. Have a varied background in predictive maintenance, prescriptive analytics, and then vibration analysis, as we'll discuss today, is kind of a strong suit, an area I've spent a lot of time in my career and have a strong passion for.
Yeah, so I guess maybe we could start there then. I don't want to start with what is vibration analysis, but about as close as that as we could get. So why are we focusing on this topic today? I guess why is it so important?
Sure. Well, vibration analysis is not a new technology. It's really been utilized in industry since the 50s and 60s, to my knowledge. Every machine has a vibration health signature, and you can pick up on those and establish a baseline and trend deviances from those. And it's really a proven and dependable method for determining machine health.
And is there particular industries that rely on this type of analysis more than others, or is it quite broadly used? Would you say?
Yeah, traditionally, I think higher risk processes with higher profit margins, where downtime costs them a significant amount of money, made investments here first. Have spent a lot of time in chemical and oil and gas and even marine industries that have invested in this technology heavily in the beginning. But really, any process, any organization, any facility that has rotating equipment is a candidate for vibration analysis. And even if an hour or two of downtime isn't particularly expensive, there are all kinds of additional benefits to vibration analysis to being predictive.
Yeah, and maybe that's a nice, you sort of led on to the next question. So what are the benefits, I guess?
There's several PDM technologies that go back quite a ways: oil particle analysis, thermography, and of course vibration. There are others. Vibration analysis is kind of that most encompassing technology, if you will. It really provides the benefits across the board, where there are some more specialized predictive maintenance testing and analysis approaches. Vibration analysis has really stood the test of time as kind of the most encompassing PDM technology.
And I guess how does it work alongside other forms of analysis as well? If we talk like temperature or torque or other, how does it sort of play with those, if that's the right phrase?
When we talk about machine component degradation, there are leading and lagging indicators of wear, friction within a system. And vibration analysis has come a long way with improved sensors, improved resolution, and sampling frequencies that have allowed vibration to really move into that, leading indicator ahead of things like temperature, typically, where temperature would be considered a lagging indicator. But it's very relational to all of those process measurements, to all of those additional parameters you might expect, pressures, temperatures, flows. It fits in quite well and often just verifies, a suspected condition.
And you said before that, there's a lot of, I guess, companies sort of using it. I mean, from your experience, do people have this already in place already, or is it something that's missing in a lot of sort of data collection setups?
Yeah. As is typical for predictive maintenance, right? There have been a lot of programs that have been absolutely phenomenal out in industry. Some have come and gone. Over time, I think some of the primary challenges has been manpower and knowledge. In the United States, I can say that there's been a huge population, a huge knowledge loss from people that have been retiring in the last 5 to 10 years, taking that tribal knowledge away with them. And it takes some time to get new engineers, new maintenance mechanics, and people well versed in vibration analysis so that they can effectively diagnose machine faults. And so it's a time investment. And you know, programs can depend on a couple of critical people in the past, and should those people depart or retire, those programs could falter.
So you're saying that a lot of companies employ sort of specialists in vibration analysis, and those people are leaving, which leaves the gaps that maybe are hard to fill. I guess it's a general problem, isn't it, across sort of manufacturing, industrial settings, right?
Yeah. There's a learning curve. It takes a couple of years for somebody to really enter that journeyman level of vibration analysis, to feel confident making, calls on whether equipment requires repair. Those types of things take time and experience, and you have to have really a passion for problem solving and a determination to just kind of keep going and learning.
Exactly. And in terms of the overall predictive maintenance picture, so where does it sort of contribute to or how can it contribute, let's say, to a predictive maintenance strategy?
Well, again, I think vibration is the most holistic approach. I think that there are many PDM technologies that are absolutely phenomenal, that do a great job of detecting. But if you wanted a broad approach to try to capture as many failure modes as you could from a rotating piece of equipment, vibration analysis is probably it. And today, there are wireless vibration sensors coming out all over the place. There are traditional wired applications that have been used. I think vibration analysis is still at the very core of every PDM effort. It really depends on the granularity and how that information is being used today.
I guess, do you have any sort of real world examples you can sort of draw upon where you've seen it sort of successfully applied?
Yeah. From my background, in the very beginning, I worked with the U.S. Navy on their mission readiness projects. They have been a firm believer in predictive maintenance to maintain mission readiness for up to 50 years now. Testing equipment, for me specifically on U.S. aircraft carriers and U.S. destroyers, quarterly surveys to take vibration readings on all of their critical rotating equipment, go back and provide reports, and that would allow them to determine what needs to be fixed during the next overhaul or downtime opportunity. And there are many, many studies and numbers across the board, not just, of course, with the U.S. Navy, but with many large organizations, that the ROI is clear. The payback, the benefit is very, very clear. I think the challenges today are what we just discussed, right? Our stability in a program, continuity, and really making use of lessons learned along the way.
And I guess a products like Senseye Predictive Maintenance helping to, because we talked about knowledge loss and that side of things. So is it products such as, and let's say teams behind products like Senseye Predictive Maintenance are helping to bridge that gap?
Absolutely. Able to, look at historical context, able to utilize trends from thousands of pieces of equipment, and really paint a full picture, right? Bring in that expert, if you will, that might be missing from the picture, to help organizations understand what is normal for a machine, what is exceptional, and then also understand different changes and things within the equipment and what that means. So I think that AI technology platforms like Senseye are going a long way to fill that knowledge gap.
I guess that also sort of leads on a little bit. So you mentioned AI, but also I guess generative AI as well, functionality, which is just, well, it's been introduced into our product, but I guess more widely as well. How do you see that sort of impacting the industry as well?
Well, there's a couple of aspects there, right? Generative AI being able to look at historical context and put some logical conclusions and some suggestions together to guide you to past events that seem to mirror or are very similar to current happenings. Um, that's huge. It's going to go back and recognize patterns, events, and piece that together. Where in the past, a human analyst might have to look back through months or years of data, and they still might miss something there. And so it's going to give you that historical review. It's going to bring things into context. It's going to bring those events to your attention. And then there's the conversational aspect of generative AI with chatbots and things where you could, be inquisitive and ask more questions and ask to reference additional data points or even, just common sense questions about changes in data and what that means. And it's just, to me, it seems to be a real big game changer.
And in terms of its impact on things, as we talk about vibration analysis, like how do you think it will impact sort of that side of things, or in the context of what we've spoken about, I guess?
Yeah, this question I love. I think for the last 5 to maybe 7, 8 years, there's been this push to release a vibration sensor from quite a few companies around the world, and add kind of a diagnostic screening capability behind that. Uh, you know, many for a few years now have been throwing the word AI in with that solution. But what it really is a diagnostic engine, rule-based, fault templates where you can put some guardrails around, you know, data you might receive from a pump, what that traditionally looks like, and certain exceedances within that data, and what that might be linked to, whether it's bearing wear or imbalance or cavitation, what have you. Um, those are rule-based templates. They are as good as the data sets they've been trained on the amount of rules that have been written, um, and on how that technology has been applied today in the field, whether the sensors have been installed correctly, whether sensors are capable of picking up the frequencies required to identify the faults. There are so many variables, and I think that this is a leap to actually say that AI is going to move beyond these static rule-based systems that require still a lot of human involvement in determining whether it's applicable in the current situation. Um, AI is going to help really close that gap. And when I say AI, specifically, of course, generative AI and conversational AI.
Yeah, absolutely. And you've mentioned it a few times actually. So on a change of tack, you mentioned about the sensor technology. I mean, how important is selecting the right kind of sensors for this analysis? Maybe it's an obvious answer, but we could dive into it a little bit. But what the
No, huge. All sensors are not the same. And again, the last maybe 10 years, a little less, wireless sensors have been all the buzz. Everybody is looking to deploy wireless sensors within their facility. Traditionally, it can cut down on the cost of having conduit and cables and junction boxes all over the place, and what seems like an expensive installation in many cases to run cables to bearings all over the place in a plant. But that said, there's been a huge sacrifice in data acquisition capability, right? The kind of data we get, the resolution, the Fmax or maximum frequency that can be obtained from these sensors. And there has been a lot of push to deploy these less than capable sensors at scale across a facility. Um, and a lot of faults can be missed. The quality of the program and the forecasting and prediction capability goes down. And for me, I'm not a huge fan of that because I think that it degrades the confidence in what is already a very proven technology. So I think, to answer your question in short, um, sensor selection is a huge part of it.
Please like and subscribe on all major podcast channels and find out more about Senseye Predictive Maintenance at Siemens.com.